All right, so let's talk about filtration. So we've coagulated, we've flocculated, we've settled things out of the system, and filtration is really the backbone of where we start to remove pathogenic organisms and we start to really polish the water so that we're ready to go when it comes to disinfection. So filtration, this is solid and liquid separation where we have a liquid passing through some kind of a porous media or material, and it's going to remove fine suspended particles. So we're now at a smaller particle size than we were when we're talking about things like coagulation, flocculation, sedimentation. We're getting down into kind of the nitty-gritty of removing those particles. When we talk about filters, filters are classified by the number of media layers that they have within them. So we can have single media filters. They're not very common. They basically all just have one media, normally sand or sometimes anthracite coal. A single media filter you might see at a home filtration system, but in a full-scale water treatment plant, it's definitely going to be what we call dual media filters or multimedia filters. So dual media filters are probably the most common. They normally use sand and anthracite. And then multimedia filters will start to add things like garnet, gravel, granular activated carbons, all of these really interesting specific types of media. So we classify filters specifically by the number of layers of media that we have. And we can also have proprietary medias as well. So companies develop media specifically for removal of specific contaminants, and those can start to get integrated into these systems as well. So filtration's purpose is threefold. It's the removal of fine suspended particles and turbidity, so any particles that remain after sedimentation. The removal of viruses, pathogens, and bacteria. So filtration is a big step in terms of getting what we call log credit removals from a system. So it's not just disinfection that removes pathogens, it's filtration as well. Filters are designed to help us remove things at that small level. And then we want to polish water before disinfection. So before we add any chemicals like chlorine or we try and hit it with UV or whatever we happen to do, we want to make sure that that water is very clear and very ready to go for disinfection. So how does it work? Filtration is based off of the principles that out in the environment we have layers of sand and soil, and the water naturally trickles through those layers of sand and soil. And by the time it does, it's clean at the bottom. And the reason for that is because as we push water through a media, there are pores between the grains in our media, and any contaminants are going to stick to those pores or are going to fill those pores, but the water is going to continue to move through. So how fast that water moves through is what we call our filtration rate. So we push water through a media which has pore spaces in between, and anything that is nasty in the water gets collected on those surfaces, and then the water is collected out at the bottom of the filter. So as those pore spaces fill up, we have to make sure that we can clean those pore spaces out, and we do that through a process called backwashing. So with backwashing, we have to clean that filter by moving water through the bed. And we'll talk about this a little bit more in a couple slides. So here's a cutaway of what a filter might look like from the side. So it's a big concrete basin. We have manifolds at the bottom where the water is collected and pulled out. We have washing troughs where water can come through in order to backwash. And then you can see we have graded gravel on the bottom of this particular slide. Let me grab my laser pointer. There it is. There's that gravel layer. And then we have sand above it. So the water is moving from top down through the bottom, and it's collected in the bottom. So this is another figure to give you an idea of what that looks like. So we'll have raw water coming in, multiple different layers, and the treated water comes out the bottom. When we backwash, it actually goes a little bit differently. We push water through the bottom of the system, it floats the media up, and then we have to get rid of that gross stuff that comes out the top, and so that's drained out the side. So these are a couple pictures of filters so you can get a sense of what this looks like. So in the top left, what you're going to see is an outdoor filter. These are very big basins when you get to an actual water treatment plant. So the diagram on the bottom left is going to show you how that top left is working. Water is coming in the inlet on the top, and you can't see it in the top left picture, but there's sand, there's gravel, and then there's water, and we drain it out the bottom. So what you're seeing in that top left, that's the top of the filter, that's not the bottom. What you'll see in the bottom right is kind of what those layers look like from the side. So you can see that there's multiple layers here, and that the depth of those layers matters, right? So you have much more sand than you do fine gravel and coarse gravel. And you'll also notice that there is a gray layer called a biological layer. So some filters specifically, we actually want a biological layer to grow, and that's going to help us to remove specific things. So we actually want to generate a biofilm on the top, and it's going to help to remove particles. The technical name for that is a Schmutzdeck. It's a German term. And then what you'll see on the top right is kind of what a filter would look like at a household level. So if we're thinking about communities in rural Appalachia, they're not going to have these big water treatment systems that are huge like what you see on the left, but you might see something a little bit closer to what's on the top right. So that's typically a fiberglass container that has 1 to 2 different types of media. And it has the same exact ideas. We have to have backwashing, we have to have all of that good stuff, but the piping is different and the valving is different. Where do we put control valves and things like that? So you can have these same style filters at multiple different levels. You can have big ones, small ones, but the principles are all the same. Some key concepts related to filters. So the pores between whatever material you're going to use in your filter have to allow water through, but they trap particles and pathogens. So normally we're talking about a very small pore size. So you'd normally choose things like sand, because sand can be packed pretty closely together and it will pull those pathogens and particles out but let the water through. As those pore fills, the filtration rate decreases. It's now harder to push water through because the pore spaces get smaller and smaller as they get filled up with these particles and pathogens. So then when that filtration rate decreases to such a specific rate, the filter needs to be backwashed. So normally we monitor the filtration rate and we monitor the turbidity coming out of the filter to know when to backwash. What a backwash does is it pushes water from the bottom of the system and it fluidizes the filter bed. And so all of the material comes up, the nasty, dirty water comes to the top and it's drained off the top, and then the filter media is allowed to settle. And so one thing that's important about what you put in your filter media is that if it's going to settle, you want the densest thing to be, or the heaviest thing to be on the bottom. Right? So gravel is heavier than sand in water, and so it will settle out faster. So we actually naturally let our filters settle back down via gravity. Same principles as settling from a sedimentation tank. We do put the densest material on the bottom, and so they're naturally going to settle out. All right, key components. So things that you need in a filter: you need your media, and different layers are going to have different pore sizes or effective sizes. And generally we choose our media based on particles or contaminants that are being removed. So media is really important. The size and the depth of your filter media are really, really critical to key filtration. And then your backwashing systems are key. So pumps, timers, all that good stuff. These are kind of the key things that you need in a filtering system. Key parameters that engineers need to know in order to do any kind of calculations: we need to know the effective size of the particle. So that is going to tell us about how big it is, which means that we can start to figure out how big the pores are in between the particles. And that's going to tell us something about filtration rate and hydraulics and things like that. We need to know the depth of the filter layers. That's really key, especially when we backwash and we think about how effective our filters are. And then we need to know something called the uniformity coefficient. So particles are not perfectly spherical, unfortunately. They have different geometries, different surfaces, that kind of thing. So the uniformity coefficient is a way of looking how spherical those particles are when we make estimations for pore sizes. So those are the pieces of information that you would need to go and find in tables in order to do calculations. And then once you have those parameters, the calculations that you can do are things like head loss, filtration rate, and backwash rate. And we'll talk about how we calculate these in class, so I'm not going to spend any more time on that in the pre-lecture. Last couple slides here so that we can keep this video nice and short. So advantages and disadvantages of filtration. So advantages is a relatively simple technologies. The principles are well understood. Sand and gravel media are relatively easy to source from a material standpoint. They're not difficult to get these things. It's a modular technology, so we can put things in parallel, we can put things in series, or a combination of both, and it's going to work really well. And it's a physical process that can be enhanced with biological processes. So we talked about that biological layer that can form. Sometimes we actually want that to form, and sometimes we don't. So it's something that can aid in treatment, and we just have to know whether or not that is actually going to aid in treatment for our system. Some disadvantages, our backwash frequency generally increases over time, and it requires operational oversight. So backwashing is something that we have to watch very carefully because the effectiveness of it over time decreases. Sand and media like gravel are normally heavy to move around, so when you actually have to replace these filters, it is a lot of manpower and a lot of effort. If you're using something like a proprietary media made by a company, it may require more maintenance and have higher environmental cost because you have to regenerate the media. And we can talk about that more in class if you have specific questions. And then if we do want that biological layer to be there, if we're pre-chlorinating and certain chemicals are too high before coming into the filter, we can actually kill that biological layer, and that's not a good thing. So we have to be aware of what pre-treatment we're using before filtration, especially if we care about that biological layer. So last couple things, what water and wastewater parameters matter. Turbidity is a big one. Turbidity is normally used to monitor when we backwash. As those pores fill up, the turbidity is going to increase over time, and so we're going to have to backwash. And so normally we use that as a way to remind us how to do that. Your flow rate will inform, this should be your filtration rate. So the flow rate that's coming into the system will inform the filtration rate. That's important. And then the mass loadings of specific contaminants. So the kilograms per day that are coming in of a specific contaminant, especially for proprietary medias, are going to be important. And then lastly, let's talk about some potential impacts, things to be aware of for filtration. Frequent backwashing can lead to filter media loss. As you push that water up through the system, you can lose media when you drain it away. You're not just draining away water. So that's important. So media may have to be removed and cleaned. You may have to process the backwash water. So the water that comes out of a backwash and that is drained has ugly things in it that we don't want. And so there's going to have to be some kind of a treatment or some kind of a discharge permit associated with that. If we have algae or larger particles that are not being removed prior to filtration, this can clog our filters. So not all filtration systems have coagulation, flocculation, and sedimentation prior to filtration. Filters can be used without those pre-treatment steps. But if they are, we have to be aware of what things could potentially clog our filters. So water quality has to be good in order for us to make it great after filtration. And then finally, media such as anthracite coal do have environmental impacts. So based on the type of media that you have, you could actually be having some environmental impacts based specifically on the types of materials that are used. So that's something to be aware of. Maybe the utility really cares about sustainability and environmental impacts. So the filter media is what's going to have those impacts on systems. So that's going to close us out for filtration. In class, we'll talk specifically about some specific parameters that you need to be able to calculate in order to design these filters.